Just going to briefly, in that case, recap on regression. So last time we looked at simple linear regression. This is just the same slides again. And that's for the case where you've got two continuous measurements and you want to measure their relationship. So here we've got white blood cell count and platelets, and it looks as if they're positively related. And that relationship can be described by a regression model. And so this Y would be the white blood cell count. We have an intercept value, a constant, plus a slope. This B represents how steep that slope is. X here would be the platelets and an error term. So that regression model can serve several purposes. It can tell us, is there a significant positive or negative relationship between two measurements, two continuous measurements? The B, the slope value, gives us a feel for how related the measurements are. And sometimes it's useful to sort of be able to predict one thing from another, and the regression gives us the scope to do that. We can predict white blood cell count here from values of the platelets. And in fact, that's the actual equation that we got. So by sort of calculating this bit, we can predict for a given value of platelets what the white blood cell count is likely to be. Of course, in practice, I don't think that would really be something we'd be interested in, but in other applications, it might be useful to know that you can predict things from a regression. Briefly mention multiple regression, where you have not just one thing in the model, one measurement, but you can put several measurements in. So that's easier to visualize through an example. If we were measuring calf birth weights and we had records of the mother's weight, the father's weight, and the gestation at birth, we could put all these into a multiple regression model, and that potentially could be used to predict calf birth weight from its parent's weight, the gestation of the calf when it was born.